Okay, so example, it's 3, because 1 and 2 were on like the first day of matrices. Example 3 just says that these matrices are completely equal. So if I asked you what element was in the first row, third column, if I asked you what element is in the first row, third column, what element would you tell me? Does it matter which matrix you were looking at to tell me -3? No, because what do we know about these matrices? They're equal. So you see some variables in there. X is in the second row, third column. X is in the second row, third column. What does X equal in the other matrix? Second row, third column, 14. So we know X is 14. Y is in the second row, first column. So we look at the second row, first column in the other matrix, we see an 8. So 2y is 8, so y has to be 4. And then which row column is Z sitting in? Which row? Third row, which column? Third column. So 3Z is equal to, in this one, third row, third column, 9. So Z is 3. Next. We then did adding, subtracting matrices, and it does say that the matrices must be the same dimensions to do this. If they're not the same dimensions, it says in the book, what do you write if they're not the same dimensions? Undefined. And when you went through and you did your notes, B and C were not the same dimensions, so that one is the one that is undefined. A plus B, you just add the corresponding elements in the same places. So first row, first column, we add them, we get -2. First row, second column, -6. Second row, first column, 13. Second row, second column, 6. For subtraction, you would have to do, same thing, you're doing the corresponding elements, but this one's 4, subtract -6. Have you guys been taught an easier way to do subtraction? Instead of subtracting a negative, what could you do? You could add the opposite. So if you wanted to, you could just say, I'm going to add all the opposites of these, and then just think about it like as addition. Maybe you make less mistakes that way. 4 plus -6, negative, just kidding. 4 plus 6, forgot I changed that, 10. And then -1 plus 5 would be 4. 6 plus -7, -1. 3 plus -3, 0. Alright. I know a lot of you already did this and checked your answers. When we go to add D or subtract D minus C, you should get 5, -7, -6, 0, -8, 4. Questions on adding, subtracting? You can do it. Then the next section you were doing on your own was scalar multiplication. That's when we have one number multiplied by the matrix. That's called scalar multiplication. It's like doing dilations back in geometry. So we're going to take 3, we're going to multiply every element in A. So we get 12, -3, 18, 9. Easy stuff. Question B, -16, 4, -28, 0, -12, 8. Then when you go to do question C, you just need to make sure you're following order of operations. So order of operations, we have to multiply by 2 first. We have to multiply by 3 first, then subtract them. Or, did anybody in here multiply by -3 instead of multiplying by +3? Did anybody do that? Me too. I multiplied by -3 and I added them instead. So you could do that also. Okay, if I multiply this one by 2, we get 8, -2, 14, 0, 6, -4. And then I'm multiplying this one by -3 so I can add them. So -27, 24, negative 3, 0, 15, negative 6. And then add them together, our final answer would be negative 19, 22, 11, 0, 21, negative 10. And then you say, man, this next quiz is going to be so easy. I'm going to ace it. I'm going to bring up my grade. Right? All right. Let's learn how to multiply matrices together. Multiplying matrices. So on the bottom of the front page is the first thing that you have to look at, the bottom of the front page, and then it continues on the top of the second page. But what it's saying in this paragraph is when you multiply matrices, you have to keep them in the order that's given. You know when you multiply numbers and you're doing like 2 times 5, you can also do 5 times 2. You know that rule? Did you know that rule? Is that new? 2 times 5 or 5 times 2, we get the same answer. But if you take your matrices and you switch their order, you're not going to get the same answer. So you've got to make sure you have the order stays the same of whatever it is on the paper. And then what you have to do before you start is make sure you're allowed to multiply your matrices, because sometimes they don't work. You want to look at the numbers when you find the dimensions of the 2 matrices. You want to look at the numbers on the inside of both matrices. If those numbers are the same, you can proceed and you can multiply. If they are not the same, it's undefined and you can't do it. So if you don't do this step first, you're going to waste your time. Because you might start doing it and realize you can't do it, because once you start doing it, it's not going to work if this is not the same. These numbers are also important because the numbers on the outside tell you what your answer matrix is going to be. So when I multiply a 3 by 2 times a 2 by 3, I will get a 3 by 3 matrix. And then if you look at example 6 on the back of the paper, that one is already done all the way. It's multiplied all the way out. They've showed the steps, which I'm going to walk you through the steps on 2 more examples. But you'll see that this is the 3 by 2 and the 2 by 3, and when we're done, we get a 3 by 3. And there's a bunch of multiplication and addition, which I'm going to walk you through that. Okay, I'll show you how we get all those numbers, but this one's already done. If you look up here, do you notice any numbers that are the same, kind of in the same location? Do you see any of these numbers that are the same, in the same location-ish? Do you know what I'm talking about? I'm not at this point. You see these negative 7s, they're all in the parentheses, and then these are all 8s in the parentheses. Do you see that? And then in the middle, we've got 22, 22, 22. We got 16s. Here we've got 1s. We got 24s. And those are all up and down like columns. And when you look, where is the negative 7 and the 8 in the original question? You see the negative 7 and the 8 together in the original question? You see how it's a column? Column numbers are going to end up in columns down here. And then row numbers, like negative 15 and negative 18, are going to end up in rows. See my row numbers? They're ending up in rows, and they repeat each other. Let me show you how you actually get them. I just want to show you that there are patterns, so you can have an idea if you're doing it right. So example 7, question A. We should first check to make sure that we can multiply them. So we find the dimensions of each matrix. How do you find dimensions? What by what? What do we do first? Row by column. We can remember RC Cola, row by column. I was writing column. So the first one is a 2 by 2, and the second one is a 2 by 1. Now we look at the inside numbers. Are they the same? So that we can multiply them. And when we do multiply them, the outside numbers tell us what we'll get. We will have a 2 by 1 when we are done. Since I know we're going to have a 2 by 1, you saw all that multiplying and adding in that other example. I'm going to set it up so I can multiply and add, and I'm going to have enough space. I'm going to write a 2 by 1 column matrix, 2 row, 1 column matrix. Here I've got 2 rows and then 1 column. But my column's a little wider because I have to add and multiply some stuff in it. okay? But I've got 2 rows, 1 column. And then I put a line so you can see that I have 2 rows. When you do it on paper, you really wouldn't need a line because you're using lined paper. A little easier to organize it when it's on lined paper. When I look at my answer matrix, my 2x1 answer matrix, and I'm talking about the top place, that is which row? This spot right up here is which row? Which row? First row? Is that what you're thinking? So first row, and then which column is it? How many columns do we have? So which column is it? First column, okay? So I know that this is the first row, first column. And I use that information to know how I get the numbers that go here. Up in my original question, I always use the row from the first matrix and the column from the second matrix, R, then C. I'm going to use the first row and the first column. And then when we multiply them together, you only multiply elements that are in the same order. So I multiply the 1, which is the first element, with the 5, which is the first element in the row then column. So I multiply 1 times 5, and then we add our second element 2 multiplied by our second element 6. 2 times 6. And then we'll simplify that in a moment. And I go, and this spot is which row? Second row. Which column? First column, the only column. So in my matrix where I'm multiplying, I do the second row with the first only column. So I do the corresponding order. I do 3, which is the first number, and 5, which is the first number, multiplying together. Plus 4 and 6 multiply together. Then we multiply and then add, and we get 17 and then 39. We have a 2x1 matrix. Remember, the lines don't go in the matrix. I was just using that so you could follow my work. It's just numbers floating over each other in the matrix. Okay? It's not bad, just got to stay organized. So let's look at question B. And we are not going to fill out question C, so if you need that space, you can just cross out question C. We're not going to do it. Question B, can we multiply them? What is the dimensions of the first matrix, the order? 2 by 3 multiplied by a 3 by 3. Are we allowed? What will we get when we're done? Excellent. So I'm going to draw a 2 by 3, but I'm going to make it wide columns so I can do all the adding, multiplying stuff in it. So I'm going to have 2 rows and 3 columns. Okay, so I just made just a big, like a table kind of, a 2 by 3 table. And then once I find the answer, then I'll get rid of all the lines. And then I ask myself, this one right here, that is which row, which column? First row, first column. So to get the numbers in there, I have to use the first row with the first matrix and the first column with the second matrix. And the numbers I multiply have to be in the same order. So I have to do the first number 5 multiplied by the first number 3. Plus, I have to do the second number 1 multiplied by the second number in the other matrix, 1, plus 2 times 5. Now when I'm doing this, I like to go to the right next and stay in my first row and just do second column. That's the order I like to do it. That doesn't mean you have to do it in that order. I'm going to do my first row up here, my first row, but I'm going to use my second column this time. And we multiply the same element, so 5 is going to be multiplied by the 1. Plus 1 multiplied by the -2. Plus 2 multiplied by the 0. So now I'm in my third spot, my first row, but my third column. Because when we're done, we're getting a 2-row, 3-column matrix. So first row, third column, I come over here and I look at my first row, and then I look at my third column. I have to multiply 5 times 2 plus 1 times 4 plus 2 times -1. All right, now I am on my second row. Second row, first column. So now I do second row, first column. So I'll do 2 times 3 plus 0 times 1 plus 3 times 5. Now I'm on second row, second column. Second row, second column. So I'm going to use the second row, second column. 2 times 1 plus 0 times -2 plus 3 times -1. And then finally, what did I do wrong? Oh, I went to the, yeah. I should notice that, huh? My colors didn't match. Thank you. All right, so that last one is second row, third column. You guys are getting this? So we got 2 times 2. Are you understanding what I'm doing? 0 times 4 plus 3 times -1. Okay. Then we just find our answers for the matrix. Let's see. Help me out. We got a 26. What's that one? Help me out. 3. I couldn't hear. What's that one? 12. What? 21. 2. 1. Good. So we write our answer. So if we have a quiz on this, which we will, it'll probably be Friday next week. There will be a non-calculator section, and this could be a question on the non-calculator section. Okay? But I would like to show you how to do it on the calculator, just in case that helps you go faster on something like an ACT test, where you have, where speed is a factor in it. So go ahead and take out your calculator, and we're skipping that C. We're going to go to the next section that talks about the graphing calculator, so I'll go ahead and just show you how to do it there. I'm going to take some good notes, and then the video will be up, so you can just go back on if you forget how to do it on the calculator. Okay, use your graphing calculator to find the product. I have it here. So when you turn on your calculator, in this first column, there is a matrix button. You find the matrix button, and you have to hit second to get it. Second, x to the negative 1. And it'll bring up some like A, B, C matrices. But to put in a matrix, you have to edit. So go over to edit. And then we'll go ahead and make our first matrix A. So we'll enter in A. Once you're in edit, just enter. What dimensions is matrix A? 2 by 3. So I'm going to hit 2, enter, 3, enter. And then every time you enter a number and you hit enter, it'll go across the row. So you can, just look at your paper and just type it real fast. Negative 2, 4. You want to hit enter each time. So enter in our matrix. You can also use the calculator to add matrices, to subtract matrices, to do scalar multiplication. But the time that it takes to enter these numbers in, sometimes it's just faster to do it by hand. It takes a while to enter these in. Okay, now we're going to go back to matrix so we can enter in B. Go back to matrix, oops, second matrix, and go over to edit. Go over first, then go down to B, to edit B. And B is a 2 by 2. So we'll enter that one in. Once you have those matrices entered, then you need to go back to the screen where you do calculations. You can do second mode to get back to that screen really quickly. Second mode works. All right. If you are stuck or something's not working right, I can't see your screen right now. You need to call me over to fix your problem before I go too far so you get really behind, because I can't see what's happening on your screens. All right. Go back to matrix. And this time we're not editing. This time we're in the main screen, the names. And you're going to choose matrix A. So it shows up in your calculation screen. And what do we want to do? What operation? Multiply. So multiply. Then we're going to go back to matrix and choose matrix B. So it should say A times B. And you guys hit enter. And it says error Y. What did I say you have to do first every time? What did I say before you multiply so you don't waste your time? You got to check those dimensions. Did we do that? No, so we just wasted our time entering in matrices because you didn't do that step, and nobody stopped me, so I kept you going. It was good practice entering them in, though. So this is a 2 by 3 multiplied by a 2 by 2. You can't do that. So undefined. If you check it first, you're going to save yourself some time. Let's do the next one. Can we do D? We got a 3 by 3 times a 3 by 3. Yes, we can do that one. So now you practice entering it and multiplying them. I will do it up here so you can check your answer to see if it worked. You practice multiplying them on your calculator. So once you have gotten the product, you can just look at the board to see if you have the same answer as me. If you do, grab a book, finish your assignment that you started last class. If you have any issues, call me over. Yes, because you didn't go to here. Clear that. You didn't go back to the second mode. now go to your A times B in that screen. You need a pick out? Yeah. Okay, so go to your second row. I have pencils over here. And there's water, right? Yeah. Okay. Now go to matrix. And first one, and then times. And then go back to matrix. You do that calculation screen to make it work. If you need any help getting that multiply matrix on your calculator, let me know. The assignment was up yesterday. I'm putting it right back up. You will only use the graphing calculator for the ones that say use a calculator. If it does not say use a calculator, then you do it by hand. And I'm going to stop the video, and then whoever has questions will come.